Hi. In this class, I will share detailed information about a router, and you will understand what is a router and how to manage a router. A router is a network infrastructure device that redirects the packets from one network to another network based on information from the network layer. A router uses a combination of hardware and software to route data from the source network to the destination network. A network router is used to connect two or more networks having different network addresses. A router is also used to divide a big network into multiple small networks. The division of the network is based on the Layer 3 addressing system. Dividing a big network to smaller networks improves the performance of the network. Dividing a big network into smaller subnets is to create small broadcast domains. As a network engineer, you should always remember the following important facts related to a router. If the network layer data packet originated from one computer is addressed to another device within the same local subnet, the router will not come in this picture, and local layer 2 device will take care of end-to-end communication. Routers act as the gateway of a subnet. Data from one network to another network will always cross the router. If data is addressed to a computer outside the subnet, the router will forward the data packet to the destination subnet. Only the IP datagram packets addressed to a computer located at another network will be forwarded from one subnet to another subnet by the router. To forward a layer 3 data packet from one subnet to another subnet, a router must be configured with a routing protocol to reach the destination subnet. Now it's time to understand the types of memory available in a router. A router or switch generally equipped with multiple storage devices, like ROM, flash memory, RAM, and NVRAM. Let's understand what these are and their functions. ROM is a read-only memory available on a router's processor board. The initial bootstrap software that runs on a Cisco router is usually stored in ROM. ROM also maintains instructions for power on self-test diagnostics. For ROM software upgrades, the pluggable chips on the motherboard should be replaced. The flash memory is an electronically erasable and reprogrammable memory chip. The flash memory contains the full operating system image. This allows you to upgrade the operating system without removing chips. Flash memory retains the data when the router is powered down or restarted. The RAM is very fast memory that loses its information when the router is shut down or restarted. On a router, RAM is used to hold running Cisco IOS operating system. iOS system tables and buffers. RAM is also used to store routing tables, keep ARP cache, and perform packet buffering. RAM provides temporary memory for the router configuration file of the router while the router is powered on. The NVRAM is used to store the startup configuration file. This is the configuration file that iOS reads when the router boots up. It is an extremely fast memory and retains its data when the router is restarted. As you know, without an operating system, the computer is unable to process anything. Similarly, a router or switch cannot function without an operating system. Routers and switches depend on the software for their operation. The Internet operating system is used in almost all Cisco devices. Cisco calls its operating system Internet Operating System, or iOS. iOS is the operating system software used on Cisco routers. Cisco IOS image file is normally stored in flash memory. The Cisco IOS provides the network services like the basic routing and switching functions, a reliable and secure access to network resources, and the network scalability. The Cisco IOS software uses a command line interface as the traditional console environment. Although there are numerous iOS images for different Cisco device models and feature sets, the basic configuration command structure is the same for most of the Cisco devices. The naming convention for the different Cisco IOS releases contains three parts. First, the platform on which the image runs. Next is the special features supported in the image. And last is where the image runs and whether it has been zipped or compressed. Here is an example. The C7200 means that this iOS image is for a 7200 series router. The letter A indicates that this has an APPN version of the iOS. The letter J indicates that this has enterprise features. The letter S indicates But this has NAT, ISL, VPDN and L2F features. The number 40 indicates that it has 40 bits encryption enabled. The MZ indicates that this version of the iOS runs from RAM and the iOS file is compressed. There are many more other symbolic indications to read the iOS features. You not need to focus more. This is not that much important. However, you must be aware of type of iOS running on a router. Now it's time to understand what happens when you turn on a router. When a Cisco router powers up, it performs a power on self-test, post. During this self-test, the router executes diagnostics from ROM on all hardware modules. During the power on self-test process, the router checks the configuration register value. If the configuration register value is 0, the router boots from the ROM monitor mode. If the configuration register value is 1, the router boots from the iOS image. If the configuration register value is 2 to 15, the router boots from the iOS image and also loads the existing configuration. After the power on self-test process, the router checks for iOS boot system commands in the startup configuration file. If the boot system commands are in startup config, then run the boot system commands. If boot system commands fail, use the default fallback sequence to locate the iOS. Now you have enough information about a router. Let's understand how to manage a router. There are no input devices for the router like a monitor, a keyboard, or a mouse. You as an administrator can choose any of the methods to communicate with the router. You can access a router by using the console port, auxiliary port, and you can also access a router by using protocols like Telnet and SSH. Basically, if there is no configuration in the router, the Telnet and SSH will not work. What I am trying to say, the primary communication with a router can be possible with a console port. Without a console port, a router cannot be accessed. Every Cisco equipment has a console port. Either it is a router, switch, and firewall. Each Cisco device is equipped with a console port. Or I would say, each vendor's network devices are equipped with a console port. This is actually a primary method of accessing the network device. The console port is used to connect a computer directly to a router and manage the router. Normally the router's console port is a RJ45 port. A special type of cable used to connect a router with a computer which is known as rollover cable. One end of the cable is RJ49 connector and the other end of the cable is serial connector. Now the question is, how to get access to the router? Does any special software is required to access the router? Yes, you need to prepare a few things before accessing the router. You need a computer equipped with a serial card and you need to install a terminal software. It could be anyone like Secure CRT, Teraterm, PuTTY or traditional hyperterminal. Also you need a Cisco certified rollover cable to connect the computer with a router. That's it. Please note that all Cisco devices are pre-configured with the baud rate 9600. Use the correct baud rate on your terminal emulator when accessing the router. Another important point is, a console connection is not the same as a network connection. You must be physically available at the location where the router is deployed or placed. Let me help you on how to set up a PuTTY software to get the access of the router via console. First, open the PuTTY software. Now you have many options to use on it, select the option serial. Second, as soon as you select the option serial, it will change the settings for serial line and speed. In the section serial line, type the correct COM port number. Either it could be 1 or any other COM port number. But don't change the settings for speed. Third, once the above two options are filled properly, click on the button, Open. Surely you will see the boot process of the router if the COM port is selected properly. That's it. In the next lecture, I will help you to understand the command line interface of the router. See you in the next class. Bye.